Here are solutions to homework set number 1 for ECE 341 random processes. The first problem is use a tree diagram to find all possibilities for two teams playing, 5-game match, win by 3, but player A starts with a 2-point advantage, is the odds. So what start out, kind of one way to think about it, is I start out with the score being 2-0. If A wins the first match, it's now 3-0 and the match is over. Otherwise, B wins and I misspelled 2. It's now 2-1. If A wins, the match is over. If A wins, it's now 3-2. Otherwise, B wins, it's 2-3. So these are all the possible ways that a match can play out. When it's a best-of-5 series, A starts with a 2-point advantage. Problem number 2 says, suppose I have two 5-sided dice. And I take the minimum of two 5-sided dice. No, I take the maximum of two 5-sided dice. In that case, these are the possibilities. First die, second die. The minimum is the number down here. If I then count up, there's 1 way to get a 1, there's 3 ways to get a 2, 5 ways to get a 3, 7 ways to get a 4, and 9 ways to get a 5. So the probability of getting a 1 through 5, of two 5-sided dice, take the maximum, is as follows. That's done through enumeration. Problem 3 is two players are playing a game of dice. Player A rolls two 5-sided dice and takes the larger of the two numbers, as in problem number 2. Player B rolls an 8-sided die. Player A wins on ties. What is the conditional probability that A wins, given that B's score is a 3? Well, since A wins on ties, A wins if A gets a 3, 4, or 5. From before, the odds are 5 and 25 of getting a 3, 7, and 9. Add them all up. The probability that A is going to win is 21 out of 25, given that B rolled a 3. Now, the reason for using conditional probabilities is it makes the match much easier to calculate. So if I want to know, given this scenario, who do I bet on, A or B? Well, I take all possibilities. There is a 1 in 8 chance that B rolls a 1, 2, 3, 4, 5, 6, 7, 8. If B rolls a 1, A guaranteed wins. If B rolls a 2, then it's A rolls a 2 or higher, or 3 or higher, 4 or higher, 5 or higher. A can't roll a 6, 7, or 8. So this is the probability of A given B times probability B. Multiply them all out, add them all up, and I get 47% chance. This is almost a fair game. So A's got a 47% chance of winning this game. That's where conditional probabilities are used. Take a complicated game like this and split it up into smaller, simpler problems. Problem number 5 is with MATLAB, I can do enumeration. For example, if I want to do Farkle, where I roll 6 6-sided dice, what's the chance of getting 4 of a kind? So here I've got 3 numbers that are the same, and the other 2 dice don't match. Well, what I can do in MATLAB is write this code. I'm going to go through every combination. So the first die is 1 through 6, second, third, fourth, fifth, 6. There's my die rolls. I'll then count how many pairs. How many 1s do I have? How many 2s? How many 3s? And then sort in descending order. So this is the frequency of each number. So if the most frequent number is a 4 of a kind, and the second most frequent is less than 2 of a kind, meaning 1 of a kind, I've got 4 of a kind. And to do the other problem at the same time, if the most frequency is a 2, the second most frequency is a 2, and the third most frequency is also a 2, I've got 2 triples, or three doubles. Run this code, and I can display how many of all the combinations of dice, how many times you get 4 of a kind, how many times you get 3 doubles. If you run that code, here's what I got. It took 1.36 seconds to run. And 4 of a kind, there were 1,800. There are 46, 656, total number of ways you can roll the dice. So that's probability of 4 of a kind for 3 doubles. It was also 1800, which is just a coincidence, but same thing, same number, same amount of time. Something that's not obvious, but with enumeration, you go through every combination and see what the answer is. Finally, we're looking at 6-card poker. The reason for 6-card poker is 5-card poker has been analyzed to death. So here's a slightly different problem. I'm going to deal out 6 cards. What's the chance you're going to get 2 pair with dealing 6 cards? Well, again, I'll use enumeration. What the code does is I deal out, go through every combination. So the first card can be any card, the second card is that card plus 1, and so on. My hand is then these 6 cards. Find the value of each card, find the suit for each card, find the frequency, and then count. If the most frequent card was 2 of a kind, second most frequent is 2 of a kind, I've got 2 pair. If the most frequent card is 2 of a kind, the second most frequent is 1 of a kind, then I have a pair. That's problem 8. So running through every combination and counting, what I wound up with is 2,532,816 ways to get 2 pair when dealt 6 cards. There are 20 million different hands, so the probability is 12%. For getting a single pair, it was 9.8 million different ways of getting a single pair, or a probability of 48%. Now, this is the advantage of using enumeration. You do get the right result. It takes a while. On my computer, this took 10 minutes to run. So you might think there should be a better way, and there is. It's combinatorics. That'll be homework set number 2. But this was homework set number 1 for ECE 341.